Hey, geometry students. In this lesson, we are going to be looking at the properties of rectangles, rhombuses, and squares. Now, we've defined all of these before, but let's just refresh our memory. A rectangle is defined as a parallelogram with four right angles. Now, that's going to mean some things for the sides as well, but remember, the definition is what it is, and then we can prove things about the angles or sides based on the definition. In this case, we're given that a rectangle, according to the definition, has four right angles, and we can prove things about the sides. Also, let's just refresh our memories on what a parallelogram is. A parallelogram is a figure, it's a quadrilateral that has two pairs of opposite parallel sides. Okay. So a rectangle has two pairs of parallel opposite sides and it forms four right angles. A rhombus is a parallelogram as well. It doesn't have right angles, but it has four congruent sides. A square is also a parallelogram that is a rectangle, four right angles, and a rhombus, four congruent sides. And those are our definitions of these three figures. Now, there are some properties that we should consider of parallelograms that are rectangles, rhombuses, or squares. First of all, a rectangle has congruent diagonals. That is not true of a rhombus. A rhombus is going to have a short diagonal and a long diagonal. In a rectangle, the diagonals are the exact same length. In a rhombus, the diagonals are going to be perpendicular to one another. And in a rhombus, the diagonals are also going to be angle bisectors. That's another important property of a rhombus. Each of these diagonals bisects the diagonals bisect the angles where they reach the vertices. All right, so knowing those properties, let's see if we can do some practice problems related to rectangles, rhombuses, and squares. First of all, in rectangle, MNOP, MO is 5.4 inches. What is the length of NP? Well, let's just think about this for a second. MO has to be a diagonal because it's non-consecutive vertices. NP has to be a diagonal because it's non-consecutive vertices. And this says that the diagonals of a rectangle are congruent according to a property of rectangles. So therefore, NP has to be 5.4 inches, the same as MO. They're both diagonals. They have to be congruent. All right, WXYZ is a rhombus. Using the diagram, answer the questions that follow. These are going to be a little more tricky. I'm going to zoom in here so we can see. All right, so WXYZ is a rhombus. And I know that these two angles are 6x minus 12, 4x plus 2. Let's think about that for a second. If I add together 6x minus 12 and 4x plus 2 plus whatever this angle is right here, why if these intersect because they're perpendicular to each other, they intersect at 90-degree angles, this has to be 90 degrees. So I'm going to say plus 90 equals, and then this is a triangle, so it's going to equal 180. Combining like terms, I'm going to get 10x, let's see, minus 12 plus 2 is negative 10, plus 90 plus 80 equals 180. 10x equals 100, x equals 10. All right, so if x equals 10, and let's see, one of the questions here is what is the measure of angle OXY? If x equals 10, it's going to be 6 times 10, 60, minus 12. So 60 minus 12 is 48. Let's see if we answered that one correctly. 48 degrees. Okay, what about OYZ? Let's go back up here and look at our properties. We know that the diagonals of a rhombus are perpendicular, and the diagonals are also angle bisectors. So if this is an angle bisector, whatever this angle is has to be the same as this angle. In other words, OYZ has to be the same as OYX. I could figure out angle OYX. Here, I'm just going to label this. Let me just label this problem B. and then we'll go down and we'll do label C. And in this case, I'm going to have 40 plus 2 equals 42 degrees. That's going to be the measure of angle OYX. And then I know that the measure of angle OYX equals the measure of angle OYZ. So that's also 42 degrees. There we go. Let's see if we got that one right. 42 degrees? Yes. And I knew that because this is an angle bisector. And I could figure out what this angle is because of the other math that we did up above. Letter D. Quadrilateral RSTU has a center point V. Ugh. This one we should probably draw out. So let's make quadrilateral RSTU. I'm just going to make it a square for now. We'll adjust it to a rhombus, or I'm sorry, rectangle. I'm going to adjust it to a rhombus or a square if needed. Or maybe we'll just observe that it's a rhombus or a square if needed. Okay, so we're going to label the vertices. Let's just shrink our font here, and then we'll go RSTU. So we'll put R in the upper right. Then we'll put S over here. I'm just going to copy this and bring it down. Let's see. Try that again. There we go. RS will make this one T and this one U. Oh, can't do that. I need to put them in sequential order. So it goes RSTU. There we go. All right, now RT is congruent to SU. Oop, it has to be a rectangle because the diagonals are congruent. And RT is perpendicular to SU, which means that if RT is perpendicular to SU, it has to be a rhombus because the perpendiculars or the diagonals are perpendicular. That means that if it's both a rectangle and a rhombus, it's a square. I can classify it as a square. And lastly, a building is made with a rhombus-shaped courtyard. If the longer diagonal walkway is 50 feet and the shorter one is 40 feet, what is the perimeter of the courtyard to the nearest foot? Okay, so let's just think about this one. If I know, I'm just going to put some lengths on top of here. Let's see if I can grab one of these. So we know that the longer diagonal walkway is 50 feet. Okay. And let's just get rid of our extra spaces. The longer diagonal walkway is 50 feet. The shorter one is 40 feet. Am I able to figure out anything about this if I know that this is a rhombus? Well, let's think about this for a second. This has to be a right angle. This has to be a right angle. So I'm dealing with a right triangle here. The right angle is here, so that means that 40 and 50 are my legs, and then the hypotenuse is out here. Okay? Once I know one side, I know that all four sides are congruent in a rhombus, so I can take this one side and just multiply it by 4. All right, so let's be really careful with this. I know that this whole walkway is 40. That means that this little side here is 20. This whole walkway is 50. That means that this little side here is 25. So this is going to be 20 squared plus 25 squared is going to equal whatever our third side is squared. Okay, so I need to take the square root of 20 squared plus 25 squared. Let's go ahead and do that. 20 squared plus 25 squared. And then we'll take the square root of that. And let's find out what we get as an answer. 32.01. Now, if I get that C is equal to 32.01 feet, I need to multiply that still times 4 to get the whole distance around. So 32 times 2 is 64. And I add 64 to 64 to get 32 times 4 is 128. And we can see that that is the correct answer over here, 128 feet. So that is how we solve that one. Okay, you are ready to use the properties of rectangles, rhombuses, and squares to solve the problems for next time.